All right. I'm going to give two back-to-back talks related to the PineMap project. And I think most of you are familiar with PineMap. Last year, at our advisory council meeting in Perry, we visited the Florida Tier 3 experiment, which is a fertilizer by through-fall exclusion experiment. So many of you have seen this experiment, and I want to report on the results from my student Maxwell Whiteman's master's project, which took place at that Perry Tier 3 location. Just as a reminder, the Tier 3 experiments are randomized complete block experiment consisting of a 2x2 factorial of through-fall exclusion, either no exclusion or 30% reduction in through-fall with troughs in the understory, combined with no fertilizer or a fertilizer treatment. So we have the factorial combination of those, obviously, which is a control treatment, a fertilizer-only treatment, a through-fall-only treatment, and then the combination treatment. And this experiment is replicated 4 times. It's a picture of the troughs at each location. And just as a reminder, there are 4 of these experiments in the PineMap project located on the edges of the Loblolly pine range. The idea was to push Loblolly pine into the future a little bit, potentially, by putting it out on the edges where temperatures are most extreme, both north and south. There's an east-west precipitation gradient, obviously, and then we're creating an additional water gradient by removing 30% of the through-fall at each of those locations. So I'll just be reporting on water relations and growth results at the Florida location, but there are experiments in 3 other locations as well. The objectives of Maxwell's study were to quantify the effects of those treatments, the through-fall exclusion or reduction treatment and the fertilization treatments on productivity, on stand transpiration, on whole tree hydraulic conductance, which is a measure of the ability of the xylem to transport water. So how much resistance or how much conductance to water does the xylem have? And then also the sensitivity of stomatal conductance to VPD. So VPD is a measure of the dryness of the air, how dry the air is. And stomata tend to close as the air becomes more dry. So we quantified how quickly or how steep the stomatal closure was as the air dried in those different treatments. One of the ideas here with all of these experiments is to provide parameters for the 3PG process model for loblolly pine so that we can have an idea of how those parameters might change given different nutrient availability and water availability regimes. So we'll be reporting on those here with Maxwell's study. This study is located in Taylor County, Florida, near Perry, on Foley Timber and Land Company property. It was planted in 2004 with second-gen open pollinated stock. So this isn't state-of-the-art genetic stock, and actually it's not even a single family. It's a mixture of families. So just as a reminder, we sort of went back and forth a lot trying to determine, to decide what the genetic makeup of these 4 Tier 3 experiments should be. And we sort of had a choice between using contemporary genetic stock and contemporary deployment practices, which would probably mean a current single, probably control cross family at each location. That was sort of one end of the spectrum that we had to choose from, and the other was to try to get more diverse stock at each site. And what we ended up going with was the more diverse genetic stock at each site, with the idea we wanted in the end to be able to broaden our inferences a little bit from these experiments and to be able to say, to some extent, that the results of each of these studies is a little bit more broadly applicable to loblolly pine as a species rather than to, for instance, a single loblolly pine family at each site. Obviously, there's still limits to those inferences, but to the best extent we could, we tried to find diverse genetic stock at each location. And you can see the other site establishment details there. So this stand was about 8 years old when this experiment was installed. This was an operational stand. We installed the experiment in the spring of 2012. So we cleared the understory, mowed it, applied herbicide, fertilized, and installed the through-fall reduction structures in the spring of 2012. This is a map of the sites. You can see there's 4 replicates of 4 different treatments. There's 16 plots on the site. Fairly large plots. The treatment plots are fairly large. For Maxwell's study, he measured a number of parameters, including soil moisture, inventory measurements, leaf area index, transpiration, tree level stomatal conductance, leaf water potential, hydraulic conductance, and then a weather station measured a number of environmental variables on the site. Some pictures of Maxwell installing sap flow probes. These were Grenier heat dissipation probes, which use a heated and an unheated probe, and we measure the difference between those to infer the rate at which water is flowing through the xylem. We also, on a subset of trees, measured radial variation. So these probes are 2 centimeters long. So typically we install those in the outer 2 centimeters or about inch of xylem. But obviously these are bigger trees than that, and the xylem goes deeper than that. So we also installed probes deeper into the xylem at the 4 to 6 centimeter level on a subset of trees to understand how radial variation occurred in these trees. We only did that on a subset of trees because, as you can see, we have to poke a lot of holes in the tree to get probes deeper into the tree. So that isn't resin, that's silicone compound, but it still is poking a lot of holes in trees. So that was on a subset. We did have to gap fill holes in the sap flow data, so Max used a couple of methods to gap fill data, either regressing trees against other trees. So for instance, if the probes went bad for a period of time on one tree, he had regression equations between that tree and its neighbor, so he could gap fill missing data in that way. If a lot of trees went out, he also had functions which related sap flow of trees to weather variables. So depending on what data were missing at any particular point in time, he could gap fill those data. And these types of procedures are really necessary for any data that's collected continuously, like sap flow data. So these data are collected on a half-hour basis, 24 hours a day. Just an example of the type of data that Max collected. These are transpiration rates in liters per hour for a sunny day, for a large, medium, and smallish tree in a single plot, along with temperature and vapor pressure deficit over that same day, as well as radiations. This was a sunny day. You can see that transpiration rate follows radiation pretty closely. This is an example of the same trees on a different day. This was sort of a partly cloudy day with some rain showers. What you can see is when it rains, VPD drops. We see a pretty close following of tree transpiration that follows those evaporative demand conditions throughout the day as radiation and vapor pressure deficit drops. So some of the results. This shows volumetric water content in the soil at 3 depths, 0 to 30, 30 to 60, and 60 to 84 centimeters deep in soil moisture sensors placed between the rows and then within the tree rows. And these are p-values for differences between through-fall reduction and non-through-fall reduction plots. And what you can see is that at the 2 shallower depths, 0 to 30 and 30 to 60 centimeters, the through-fall reduction treatment reduced soil moisture to some extent. At deeper levels, 60 to 84 centimeters, both within the rows and between the rows, there was no effect of through-fall reduction on soil moisture. So at depth, there was no effect of the through-fall reduction treatment on soil moisture. So keep that in mind as we look at the physiological data. So these are productivity results. So what we have here are basal area growth in 2012 and 2013. These are the values of basal area growth for the control, through-fall reduction only, fertilizer only, and then the combination treatment, as well as the p-values for those different main effects and their interactions. We also have data for leaf area index in 2012 and 2013, and then litter fall, so the total litter fall in tons per hectare for 2013. So the take-home message here is that in terms of productivity, the only treatment that had a significant impact was the main effect of fertilizer. So fertilizer significantly increased basal area growth in both years, leaf area index in both years, and litter fall. So that we did see an increase in leaf production in LAI and an associated increase in basal area production and productivity. No effective through-fall reduction, and there was no interaction between those treatments. We looked at hydraulic conductance, which is a measure of the ease with which water is pulled through the xylem. There was no difference among any treatments in hydraulic conductance. You can see Max did this measurement at multiple times through about a 1.5 year period. And while hydraulic conductance did vary over time, there was no significant effect of either the fertilizer or through-fall reduction treatments on hydraulic conductance. The idea of this measurement was that potentially, if trees are under drought stress, xylem can start cavitating, so the water column starts breaking in different tracheids, and that starts blocking portions of the xylem. If that occurs, we would expect to see a reduction in hydraulic conductance as a result. We did not see that effect. This was a wet year, yes, of course, because we installed a through-fall reduction treatment. So yes, it was a wet year. Radial variation of sap flow. This is just an example of some radial data for a single tree. So we have the 0 to 2 and 2 to 4 centimeters. On the bigger trees, we also had 4 to 6 centimeter depths. And what you can see in general is that there's a reduction in the rate of sap flow as we go deeper into the tree, which has been observed in a lot of different studies. So we did see a significant reduction in sap flow in the 2 to 4 and 4 to 6 centimeters depth. So what these bar graphs show is this hatched. This shows the percent of sap flow for a particular ring of xylem relative to the outer ring. Okay, so for example, this shows for the control treatment that the 2 to 4 centimeter ring had sap flow that was 88.7% of the outer ring. And the 4 to 6 centimeter depth had sap flow that was about 59% of the outer ring. So significant reduction in sap flow rate with depth. there actually was a significant effect of fertilizer on that relationship. So basically, that inner ring, that 4 to 6 centimeter ring, had slightly higher sap flow rate relative to the outer in the fertilizer-only treatment. We don't know why right now, but that was a statistically significant result. Okay, so there is radial variation. We apply, so Max took these patterns of radial variation and applied them to all the trees. So basically, what this tells us is that if we measure just the outer 0 to 2 centimeters and use that to calculate a whole tree transpiration rate and scale that up to the plot, we'll be overestimating transpiration. So Maxwell used these relationships to adjust the outer ring that he measured in trees in every plot to get an adjusted and corrected sap flow rate that he could then scale to the plot to estimate stand transpiration. So these data here show stand transpiration in millimeters per year, again for the different treatments, and also the maximum rate of transpiration. So you can see maximum rates of transpiration are about 2.5 to 3 millimeters per day, about 1/10 of an inch. Also, 2 parameters. So these 2 parameters express a reference stomatal conductance. So this is a stomatal conductance, sort of a measure of the openness of stomata at the tree level at a reference vapor pressure deficit, as well as a slope, the rate of decrease of stomatal conductance with increased vapor pressure deficit. So all of these physiological parameters in the end had no response to any of the treatments. We didn't see any variation in transpiration, totals or rate, or stomatal conductance, or response to vapor pressure deficit. None of those responded either to the fertilizer treatment or to the through-fall reduction treatment. Sort of, you know, as physiologists, we really hate negative results, even though we get them all the time. Okay, so we're interested in taking apart the responses to the extent we could. So what these data show are monthly values of transpiration rates. So over a 1-year period, transpiration rates in millimeters per month by treatment, as well as stomatal conductance, leaf area index, and then radiation and rainfall over those months. What we can see is that in drier months, the fertilizer treatments, which had higher leaf area index, did have higher rates of transpiration than the other treatments. So we can discern an effective treatment in some months, but over a year-long period, that effect is not detectable. But that elevated leaf area index with similar levels of stomatal conductance result in higher rates of transpiration in the fertilized plots when evaporative demand is high. Okay, so I'm parsing a lot here. What we're seeing is that there are some physiological responses occurring here. Well, really, architectural responses in terms of elevated LAI and potential shifts in water relations that could occur under drier conditions. So we calculated some parameters for 3PG, this physiological model that we're using in PineMap. And these are basically parameters of 3PG that are equivalent to the ones I showed you earlier that are a reference stomatal conductance and then a slope which shows the rate of decrease of stomatal conductance with vapor pressure deficit. And again, there was no effect of any of the treatments on those 3PG physiological parameters. But what we did also do was compare the parameters that Max calculated for his measurements with the reports in the literature for loblolly pine for these particular parameters. And what we found was the maximum value that Max calculated, this maximum conductance, was actually exactly what had been reported in the literature, but that slope, the rate of reduction of conductance with vapor pressure deficit, was much steeper in our measurements than had been reported in the literature. So Max, as well as Carlos Gonzalez, dug into the sap flow literature and found as many examples of VPD response as we could, and sort of assembled a literature data set looking at the response of stomatal conductance to vapor pressure deficit, and found that slope from the literature, assembled from literature studies, was similar to what Max had found. So we probably need to revise that response to vapor pressure deficit in the 3PG model for loblolly pine against what has been reported previously in the literature. So in conclusion, that 30% reduction in throughfall, which is significant, that's on the way highest end of precipitation reduction predictions, and probably greater than is being predicted right now in terms of precipitation reductions. We did not see an effect in this particular year of study. The trees really had access to water at depth. We saw no variation in water potential among the treatments. So basically the trees, deeper roots, and not terribly deep, but a foot or two deep, had access to water throughout the year. As you might expect, fertilizer increased productivity and did increase stand water use during months with high vapor pressure deficit due to increased LAI. And I already talked about the stomatoconductive functions in 3PG. So I want to acknowledge a lot of people that gave impact and gave input to Max in his study, as well as Foley Timber and Land Company, which hosts this study, and the USDA, which funded PineMap. So, any questions about those data?
What's your current knowledge of the other sites?
So yeah, and that's a really good question, Marshall. And some of the other sites are seeing effects of throughfall reduction. Lisa Samuelson, one of her students, has a really nice set of physiological data, and they actually are seeing an effect of throughfall reduction physiologically, and I think maybe even some main effects and interactions of those treatments. So, some of the other sites are a little better drained than we are, and that's great. I think what we're going to end up with is a nice set of data that reminds us that sites vary. And as we're looking forward, we're going to need to take a lot of factors into consideration, including, drainage, soil drainage, and soil conditions. So, but the other sites are seeing some effect of throughfall reduction. Wayne?